What's up everyone, this is Filip from Moralis.io. In this video I'm going to show you how to build a serverless dApp using Web3.js and Moralis.io of course. And what we're going to build today is actually a casino application where the user is going to be able to flip a coin and double their money or lose it all. And the end result will look something like this. And so here is our coin flip game. And not only here can we input the amount we want to bet, we can select heads or tails, and zoom in here, and we can take the flip. We can log out, of course, because we log in with MetaMask. And we also have this dashboard here, or leaderboard of top winners, top losers, and biggest bets placed by address, of course. And you might say that, hey, why do we need servers at all in order to build a dApp? Isn't it decentralized? Well, in order to create leaderboards like this or any sort of statistics where you accumulate data, aggregate data, you need some sort of server. And what we do with Moralis.io is that you don't have to care about that at all. It's super simple. It takes just a few minutes to set up, and you can start collecting this data and executing code, aggregating this data to create leaderboards like this, top winners, top losers, biggest bets placed, and a lot more without running any server of your own. It's super easy, and I'm going to show you step by step exactly how to do it. But before we do that, of course, we're going to start from scratch. We're going to start by creating our project, and I've left the link below to a Moralis.io boilerplate code where we get the login boilerplate, which will give you index.html and main.js, which will look like this. It will give you, let me show you here. It will give you this, just a welcome statement and a sign in with MetaMask button, and that is where we're going to start. So you can get that code from the Moralis GitHub, which I've linked in the description below. And with that done, we have the starter code that we're going to use. Now you also need your Moralis.io credentials. And if you haven't gotten your credentials yet, you need to go to Moralis.io. And here, let me remove this. You want to click Get Beta Access and fill in your email here. And then we'll reach out to you very soon to give you your credentials. And once you have that, you'll be able to sign in over at the Moralis dashboard. So once you've gotten your credentials, you can sign in here, and then you'll get into the server dashboard, which looks like this. You have all of your servers, and you can access the dashboard for that server, cloud functions, or you can update and restart it. And for this app, we're going to add a new server. Click on that, and here we can name this YouTube demo, whatever you want to name it. Doesn't really matter. Select your region. I'll select Frankfurt in Germany. And then finally, what network you want to use, mainnet, testnet, or your local dev chain. For this, I'm going to use the local dev chain so that I can very quickly develop some transactions, interact with this dApp without having to go through the testnet or the mainnet. So I'm going to add that, and then I'll have to wait for this server to get booted up and configured. And then after that's done, I'll get back here and we can grab the credentials for this server and input it here into our code. It can take quite a long time, so go grab a cup of coffee or something and then come back. Now the server is back up, and I can get my credentials here by clicking View Details, and that will bring up my credentials here. I need the application ID, copy that into my code at the top here where it says Insert App ID, and then I need to get the server URL, copy that, and get it inside here. Now when I have that, I can actually log in to my app. And by the way, if you don't, you need a web server for this. So you can't just open up the index.html file. You need to either have, for example, a Python web server, or if you're in Visual Studio Code, you can install this app that's called Live Server, and you can just click the button right here where it says Go Live, and that will host a web server for you. Okay, so here it is. But I can also link to a Python web server that you can use. That's very easy to use. So now when we have this, we can click Sign in with MetaMask, and it will bring up this MetaMask window here. And here, I can select the account that I want to use and then click next and then click connect, and this will just sign a message. It's here, sign, that proves that I am the owner of this address. So I click sign, and then I'll get a notification here that says user logged in. And if I check in the console, we have printed out the user here with its ID and so on. Now we don't have any attributes for the user apart from the address and so on, the standard attributes, which you will be able to see in your Moralis database. But that just shows us that the user is actually logged in. And that's of course done here in the main.js file with this line of code right here, Moralis Web3 authenticate. And then we console log the user, we alert user logged in. So now when we have that Moralis connection set up, we can actually start by adding our layout to this file, because we need a few more things in order to make this this application come to life. We need to have the input fields, the buttons, and so on. So we're going to add that in our index.html file. So in the container here where it says sign in with MetaMask, we're going to add a few things below that. So we're going to add an input field, type number. And we're going to give it an ID, which is amount, because that's where the user will input the amount that they want to bet. And we can actually make it a bit easier for us here. We'll add two buttons here. One will have heads button, play heads. So for the different sides, instead of having that toggle button, which requires a little bit more code, we'll just have the heads and tail sides of the coin be different buttons. And then we'll have the amount that we want to bet. And now we just need to add, well, we can save that and view it in the browser if you want, but we're also going to add the different handlers for these buttons. So whenever we click these buttons, so I'm now going into the main.js file, and we're going to add we have this on click handlers for the heads button, and we're going to execute the well, I don't have that function yet, but we'll create the function that we'll call it flip, let's say. And then we'll copy this row for the tail button. Tails button is what we call it, I think. Yes, heads and tails button. There we go. And now we just have to build this flip function. So let's construct this flip function here. It's going to be an asynchronous function because we're going to be calling a smart contract. We're going to call this flip. Let's actually take this as an input here. We're going to take side. So that would either be heads or tails. And how do we do that, since we just assign this function to the on-click handler here? Well, we'll create a function here where we'll call flip for heads, like this. And we'll do the same thing here for tails. You see what I did there? Because I can't do this. If I were to do this, then this would execute the function directly right here, and it will attribute the result, whatever this function returns, back to onClick. But we want the actual onClick function to be the flip function, and we want that to execute whenever we click. We don't want to execute the function here because that's what the parameters does, the parentheses does. So instead, we can pass in a function that in turn has the flip function inside of it with the heads parameter. So this will allow us to execute this function with the two sides of the coin. So let's just test out what we've built so far. So we will alert here in the flip function the side that we passed in, and let's see if it actually works. So I'll go back to your dApp here. Now you can see what it looks like, and it doesn't look too good, but you know, we can fix that later on. So first of all, if you click this, it says heads. If you oh, I misspelled this, but it says tails. Okay, so this is heads, this is tails, but I didn't name them, or I didn't put the values here correct. So play heads, and this should be play tails. Okay, there we go. But all of these things are now available even though I might not be logged in. So we need to make sure that we only show these three things when we actually have signed in. So we're going to wrap all of these things in a div, and we're going to give this the ID, let's say game, and we'll put all of this inside of here. Oops, And we can set this to style equals display none. So this will be hidden from the beginning. And then we'll wrap this button. Well, we don't have to wrap it in anything right now. This is the login button. So whenever the login is done, which is here, we want to hide the login button and display the game div, okay? So we're going to, whenever we logged in, we're going to hide the login button. So display, style.display is equal to none. And then we're going to do the same thing, but for the game div, so that had ID game, we're going to set style display to block. Okay. So now we are not logged in. We're going to click sign in with MetaMask. Now we might be signed in already, so that might be a problem. We're going to sign in, and now I think we'll get an error because we are already logged in. So let's make sure that we check that too. Now you'll learn something else. So when we come into this app to begin with, well, let's say when we press the login button, we can check user equal to await moralis.web3.current. Let's see, moralis.user.current. And that will give us any user if the user is already signed in, if it has a valid session. But if user is not defined, then we have to sign in again. If user is not defined, then we will sign in again. And once we get past this, we'll make sure to alert that the user signed in and hide all the elements I want to hide. Let's check this now. Sign in here, user logged in, perfect, and now we get our elements. All right. So now we need to connect this to a smart contract, right? Because whenever we input an amount here and we click this button, we want to send this to a smart contract and then, of course, wait for the result and to parse that result and display it on the page. And then later on, we're going to get on with the statistics and all of this. One more thing that we can do, however, is that we can make sure that inside here we get the amount of the input field, okay? So we had this input field right here, which had ID amount. In this flip function, we will need that amount as well. So let amount be equal to document.getElement by ID for amount.value. Oops. And then we can alert side plus value. Let's see if that works. Click sign in, user is already logged in. We'll input an amount here, play heads. Let's see, so something is not right here. Let's see what we did wrong. We saved this to amount, alert. Okay, so we should alert amount. There we go. Let's see, we refresh, we do this again, user logged in. We need to fill in an amount, of course. There we go. We get the amount as well. So that's all we need in order to continue, right? When we have that, as I said, we need to start working on the smart contract. And the smart contract I've already prepared for you. So we're going to just add it into our folder here. And I'll share the link to the smart contract below so that you can copy all of that into your code. So we're going to create a new folder. I'm going to call it Truffle because we'll use Truffle for this. And if you don't know Truffle already, there are plenty of tutorials on YouTube. But in this folder, we're going to navigate in with our terminal in order to initialize this. So view terminal. And let's see, I'm here. So I'm going to go into Truffle folder. And then here, I will first go npm init because we'll need to install a few npm packages. And you'll have to skip through these questions. Once that's done, you'll have a package.json file in there. But then we're going to do truffle init. And you'll get the question if you want to proceed, even though the directory is non-empty. You want to press yes. And now you have the famous 3 Truffle folders: contracts, migrations, and tests, together with Truffle config. Okay. Now we're going to go to the link that I sent you and get the first file here, the contract file. So here is that. It's the flip contract. and open that up. And we're going to copy all of this. And it's pretty straightforward. We're going to create a new file in our contracts folder, call it flip contract as well. Enter that here. And as I said, it's pretty basic. We have a flip function. You can read through this in detail if you want, but it just uses pseudo randomness. So this is not recommended for production, this type of randomness. If you want to know more about randomness, oracles, and so on, you can check out many of our great courses in the Ivan on Tech Academy. I won't, this is not a smart contract video, so I'm not going to go through the smart contract in detail. You can do that on your own. But we have that contract there, but this relies on a few Open Zeppelin modules, so we need to install Open Zeppelin as well. So npm install at Open Zeppelin /contract. Okay. And that will give us, in our node modules folder, we'll get these these Open Zeppelin contracts, which is what we need right here. You can go ahead and try to compile this contract, truffle compile, just to make sure that everything is correct with our dependencies and so on. So I have a problem with my Pragma version. So this is anything above 7.5. So I need to go into my truffle config and make sure that I have a correct compiler version here. So I'll go ahead and set 0.7.5 and try to compile again. There we go. All right, so when we have our contract done, we need to deploy it. And for that, we're going to use Truffle, of course, but we're also going to use Ganache. So you want to have a Ganache node up and running. You can download it from trufflesuite.com/Ganache if you need that. But that's just a local Ethereum node that will emulate an Ethereum blockchain for you. All on, only you will use it. So here we have block 0. And in order to deploy to that, you need to have it up and running. And then you want to go into Truffle console, okay? You want to open that up in your terminal. And then it will say Truffle Ganache. If it doesn't say Ganache, then you'll have to look more into your Truffle config and maybe set up the networks there. But it should default to Ganache. And once you have that there, you can, I almost forgot, because here we're going to run migrate. But we don't have the migration file yet. So we need to go into the migrations folder, pick a new file, name it 2_contract migration.js. Doesn't matter what you name it though, but it needs to begin with a 2. That's the important part. And then you want to get the code also from the repository that I linked below. Inside Truffle, you want to go into migrations, get the second contract migration file, copy everything here, go back, paste that in here, boom, ready to go. Let's run the migrate command. It will compile the contracts and then it will deploy them according to these files. There we go. So that's deployed. And now we're ready to start placing the actual bets. So in our main.js file, when we run the flip function, we want to submit this to an actual smart contract transaction. Send it to the smart contract, place the bet, and either win or lose money. And in order to do that, we need to first create the contract instance variable, which is how we interact with our contract. And we do that by creating a new Web3.js contract object. So we say new web3.eth.contract. And in here, we need to specify the contract ABI followed by the contract address. Okay. And how do we get the contract ABI? Well, we go into Truffle and then inside build and then check out flip contract. And then here we'll say ABI. You want to copy from this array parentheses here. When you copy that all the way down to where it says metadata, that's where it stops. Okay, you want to copy that, and we're going to create a new file in our root directory here called abi.js. And here we're going to say window.abi equal to, and then all of this. You paste that in there. And then you save that, and then we also need to import that here into our index.html. So let's also, we can copy this line right here and then paste in a new line in our header here where we will import abi.js. Okay, you want to have that above the actual main.js, we can have this in the header. And then we can just use, what did we call it? Window.abi, right? So we can just say window.abi for our ABI, and then the contract address we can get from Truffle. So Truffle here spit out for the Flip contract, the contract address. We can copy that and we can paste that here. Okay. Oh yeah, actually, before we use Web3 here, we need to define that. So we're gonna say that window.web3 is equal to await moralis.web3.enable. So we need to enable that in order to get the web3.js object. We're going to get that into here, window.web3, and then that's what we use right here. All right, keep in mind that this is a capital W right here for Web3. With that done, we have our contract instance, and now we can actually create our flip. We write contract instance dot methods dot flip, because that's what it was called in our contract. It was called flip. And we can look inside and see in the flip contract to see what parameters we need. The only thing we need is the side, so either heads or tail, and it should be either 0 or 1. So heads would be 0, tails would be 1. And then we also need to input message.value. So we need to actually attach some ether into it in order to place our bet. Okay. So first of all, the side I want to bet was here, right? So we inputted the side here. So if side is equal to heads, then we will input 1. If it's not, we'll input, or sorry, 0. If it's not, we'll input 1. So tails will be 1. Another way to say this would be that if side is equal to heads, then we'll set side number equal to 0, and then else we'll set side number equal to 1. Both of these will work fine. We can use this instead of this. Depends on your style. Okay. I'll remove this alert thing. And then we also need to attach some value to it. So, and that we do by attaching an object at the end of this, where we say value is going to be, and that is the value that we got here, the amount. I'm going to input that there, okay? Because that's what we inputted in the input row in the HTML. The last thing we need to enter here is what address we want to send this transaction from. And this is, of course, we want to send it from the person that is actually signed in, right? The person that's signed in through MetaMask, we want to use their current address. And MetaMask lets us get this address by writing ethereum. They will expose that object into the browser window. So ethereum dot selected address, like that. Okay. We need to specify value and from. And when that is done, then this call to flip is done. Now all we need to do is to listen for the response. And this is standard Web3.js. Then later on in the video, we'll get into the special Moralis stuff, where we'll be able to collect all of these stats, aggregate statistics, save data about our users, and so on. But for this, we'll do on, so .on, receipt, and then the second argument here is a function, which will take the actual receipt, as it's called. And the receipt is what we get back from the blockchain whenever the transaction has been added into a block, and we know the result of the transaction, okay? And here we can just console log the receipt, and in here we will see whether we won or lost, because in the flip contract we emit an event at the end where we tell the user if they won or lost, okay? And this is what we're going to print here to the console. The events are within the receipt, okay? So let's see if we actually managed to code all of this correctly, or if we made some error along the way. So let's go back to our browser and let's check it out. So we're going to update this. We're going to sign in with MetaMask, user logged in, and then we're going to enter our amount here. I'm going to open up the console just to see the result here or any errors that come up. I'm going to say I want to play heads. Invalid number of parameters. Let's see, what did we do for Filip? All right. So this is actually not how you do it in Web3.js. That's truffle. Okay, so how do we attach an actual options object to the function calls? Well, we do .send, and then in here we paste the options object. Okay, so that was the error. Let's save that and go back. Let's refresh. Sign in with MetaMask. Already signed in. Bet 100, and this is in Way, by the way. So we input it in Way. If we want to input it in ETH instead, we have to do a conversion in our JavaScript. It's pretty easy, but for now, let's do it in Way. So let's say we want to play. Now we get our MetaMask window here, but it says that I have insufficient funds. And that's, of course, because I haven't added any of the accounts from Ganache. So I need to input one of these accounts. So let's take this account, for example, the top account. I'm going to copy the private key. And this private key is not sensitive because it's just from my local blockchain. So we're going to reject this transfer. And then we're going to go into MetaMask and click on this account window here. And then on import account. And here you paste your private key string in there. You click import. And now you will see that you have imported your new account. The only thing you need to do now as well is to go to the top here and select Ganache. Oh, if you don't have that configured already, you also need to go into, you need to click this window up here and go into settings, and then down to networks. You need to add a new network. You need to input whatever you want to call it, the RPC URL from here, from Ganache, and the chain ID is 1337, don't ask me why, and then click save. Okay, then you can select Ganache here, or whatever you want to call it, and now you will see that your account actually has the same balance as it says here. So now we do have the enough balance to actually play. So let's play Tails. I need to sign in with the new account. So let's refresh and make sure that I sign in with the new account. Let's see, did it do that? Okay, so I actually have to switch. I clicked on MetaMask and I have to switch to the new account that I want to use, or rather, this one that I need to connect this new one. So I'm going to connect that. And now it should be okay, so let's see. Or maybe I need to refresh again. No, there we go. Okay, so now I can actually play here, and I can click confirm to send the transaction, contract interaction, confirm. And here I get the receipt, and we can look at the events and see that the bet, let's see here, return values, win was false. Too bad. Let's try again. It's hard to win here, I'm telling you. Let's play Tails again. Confirm. Oh, now I actually won. Oh, look at that. And of course, if I bet 200, I win 400. That's how the contract is created. Now, this is all good. What we can do before we start with the Moralis stuff is to just in here, if receipt dot, let's see, what was it, events dot bet dot return values dot win. If that is true, then we will alert you won, else we will alert you lost. Okay, pretty simple. So instead of having us look in the console, we can just look at the alert statement. But what we want to do now is to make sure that all of the bets that we play, they're actually save them to our database, so that we can display to the user their betting history, so that we can compile these leaderboards of the biggest wins, the biggest bets, the biggest losers, whatever that is, whatever we want. But for that to happen, we need to save into our database all the bets that happens. And this is possible with Moralis, and it's super easy. And what that allows us to do is to collect all of the different events that happen, the bet events in this case, that we created in our Filip contract, this event. Whoever executes that event on this contract, if this was on the mainnet, for example, every one of those events would be piled into our database together with our users. So that's pretty cool. And I'm going to show you how we do that now. And I promise you, you'll be surprised on how easy this is. We're going to go back to our Moralis server dashboard, and we're going to click on view details on our YouTube demo server. We're going to click on Ganache proxy server, because here's the issue. When we run a local blockchain, it just runs on our computer. So Moralis, which is in the cloud, don't have any idea what's going on our local Ethereum node. If we run the mainnet or the testnet, this will not be an issue. But when we run our local Ganache node and is testing, we need to install a proxy that will send all of this Ganache data to the Moralis cloud, okay? And you need to follow the instructions here in order to get that up and running. It's very easy. You just download one app, you input this into the configuration file, and you run it in your terminal, okay? And when you run it, it will look like this, okay? Well, I will actually need to change my configuration. So after you've downloaded this app right here, you need to locate the folder, and then we're going to edit the FRPC configuration file. So here, I'm going to input my new password and this new URL. Oops. I'm going to save that to this configuration file, and then I can run this proxy again. There we go, start proxy success. And then it should say connected here pretty soon. Let's see if I added the right details. There we go, I just need to open it up back again. And if you're on Windows and you're downloading this, some of the latest version for me as well on my Windows computer will say it's a virus of some sort. And what I did is that I just went back and downloaded the past versions. So I tried to go back to some older versions and they were fine. So I don't know why that's the case. I really don't think that's anything weird with this proxy. It's an open source proxy solution, so should be all right. And as I said, the old versions don't have this warning, so you can go ahead and use those if you want, like I did. But with this connection done, our Moralis instance now sees what happens in our Ganache Ethereum node, okay? Now the last thing that we need to do in order to start to get these events into our database, because let's actually go into the dashboard, the server dashboard. So let's click on dashboard, and we need to bring our login credentials from server details. We need to copy the dashboard user and dashboard password, and we need to enter them here. Now you can see that we have our tables here in the left. So the user table will just have one user now, because that's the address that I was using. We've just had one account so far, but we don't have any other interesting things that are about my event, because Moralis doesn't know about my event. We need to tell it to listen to the event that I created, and that we do in the Cloud Functions window. So click on Cloud Functions, and in here you want to select Add New Plugin, and then select Real-Time Events. All right. And then we're going to add a short description of what this is. So this is Flip Events for Casino Dapp. The topic that we're going to listen to is the name of the event and the parameters in the event. So we're going to go to our code and into, let's see, the contract, and we're going to copy the name of the event and the parameters like this. We're going to paste it here, and what we can do then is that we need to remove everything that is not the type. So we're going to remove all the names, all the indexed, and so on, and we're just going to keep the types, because that's all that Ethereum takes into account when we talk about the topic. It's the name and then the parameter types within it. And if you have any parameter like I have that's called uint, you need to rename it to uint256. And then we're done with the topic. Then we're going to get the ABI, but not the ABI for the entire contract, but the ABI for this event. And that you will find in the ABI file. If you scroll down, so this is one object, and the next object is this one. And this is, as you can see here, name bet type event. So this is our event. We're going to copy that object, paste that in here. That also describes what type of parameters these are. And then finally, you can input the address if you want to focus on one specific contract, or if you want to catch all the events for all smart contracts. For our use case, maybe this is not a common event, but if you, for example, have an you want to listen for a transfer event. That happens in every ERC20 contract in the entire Ethereum ecosystem, right? So then you will get a ton of different events unless you specify the address you want to listen to, okay? Finally, we'll specify the name of the table that this will be inserted into, and it will create a new table for us, so we can name it wherever we want. I'm gonna name this Flips. Then we can click on Add Plugin and then Save Plugins. This will reboot our server, install the plugin, initialize the new table, and so on, and then we're good to go. So we're gonna wait for that, and then we'll go in and check out our table. So now it's finished, and we can now go back to our Moralis instance here and update it. And you will now see a table that's called Flips. And here you will find your 2 events. And if you're having problems, if this did not create for you, then probably you either don't have your proxy set up correctly, or you've entered the event topic wrong or the ABI wrong. So make sure to double check that, especially with the uint256 and so on. And also you need to have some events in your history, because otherwise it won't create the table, I think. So you need to have some events that you've done. You can see here object ID, you can see the timestamp of the block, you can see the user that did this event, so that's me, one of the addresses from Ganesh. You can also see the bet that I made, 100, 200 way. The address here, that's the address of the contract. You also have the side, so 0 was heads, 1 was tails, and then you can see if I won or lost. So this is truly amazing. And now that we have this will now automatically be populated. So if you do another flip, we go back to our contract. Let's see, is it this one? Yes. Sign in with MetaMask. Let's play again for 500. Confirm. There we go. I lost, unfortunately. Let's play again. 400. Want to win. I won. Okay. So now, if we go back here and we click refresh, we now have 2 more events. So that's super cool, and we can see here that I won one of them, I lost one of them. All right. Very cool and very, very easy to do. Now, the second part is, okay, how do we then query this and get it into our dApp, building leaderboards and stuff? Because now we've saved the data, and of course this connects to users because you have the addresses here. How do we then display it into action, to real life statistics that we want to use in our dApp? Well, in order for this video not to get too long, I'll take that in the next video. But now you really know a lot about how to build a dApp using Moralis, using Truffle, you know, connected to, and how to get the events inside of Truffle. In the next video, we're going to talk more about these cloud functions, because that's what we're going to use. So we have to do all of these calculations on the server side, and then we can send the result back to our client and display these leaderboards on in our dApp. So stay tuned for that. And if you have any questions about developing with Web3.js or Moralis or Solidity, don't hesitate to leave your comment down below, and make sure to check out Moralis.io. And if you want to learn more about smart contract programming and how to do that, you can check out the Ivan on Tech Academy, as always, where I teach. But I want to thank you for watching, and then stay tuned for the next video where we're gonna follow up with how to do cloud functions.